Hello, I'm Susie Newhand from Birkbeck, and I'm going to be showing you how to factorise and solve quadratic equations. Yeah, just a quick apology for the soft focus on the screens that are coming up. Unfortunately, it was the price I had to pay to turn off autofocus, which was focusing in and out as I moved my hand across the page, which was certainly making me feel seasick and probably would you too. So I apologise. It's not as sharp as I would like, although I believe it's all legible. Okay, so we're not just going to factorise these quadratics, we're actually going to solve them. Although once you factorise them, it's quite easy to solve them. So, why do we need two sets of brackets? Well, we need two sets of brackets because there's no common factor, so we can't do the other sort of factorisation. These are all quite different, so we need a very special sort of factorisation. So the first term in each bracket will be x. That's quite straightforward because those two will multiply to make x squared. But what goes in the rest of the brackets? That's the big question. Well, we need to find two numbers that multiply, this is just the way I write it, multiply to 6, but add to 5. So what are the two numbers that multiply to 6 and add to 5? Well, it's not 6 and 1, it's 2 and 3. So those are numbers we put in. So that's the factorisation done. Now what about this solution of the equation? Well, we use this very, very clever bit of logic that now we have it in this form, and this is why we put it in this form, that it's in the form of something times something equals 0. Now, if something times something equals 0, then we know something really important about those things. We know that one or both of them must be equal to 0. So we use that logic to solve it. So we say that either x plus 2 is 0, which means that x equals minus 2, or we know that x plus 3 is equal to 0, which means x is equal to minus 3. So we consider both of those as solutions to the equation. Right, how about another one? So in this one, we need two numbers that multiply to 12, but add to 7. And we're going to need two sets of brackets, and we're going to put an x in each. And the two numbers that multiply to 12 and add to 7 are 3 and 4. So here are 3 and are 4. So our solution is that x plus 3 equals 0, which means that x equals minus 3, or x plus 4 equals 0, which means x equals minus 4. So there are two solutions to our quadratic. Okay, how about another one? Right, so two sets of brackets. In fact, you could always pause the screen at this point and try this yourself. Anyway, we are looking for two numbers that multiply to minus 18. If there's a minus, it has to go with it. But add to 3. Now, when two things multiply to a negative number, we know that one of them is positive, one of them is negative. That's the only way you can get a negative result. So we need a positive number and a negative number. But when they're added together, they've got to make plus 3. So what's it going to be? Well, it's going to be 6 and 3. But which one's going to be negative? That's the question. Well, if we're going to add them together and they become positive, then the biggest number must have been positive. It's the one that wins out. So the biggest of them is always the same sign as that second term. So then we know it's x plus 6, x minus 3. So solving them, x plus 6 equals 0, x equals minus 6. Or x minus 3 equals 0, which means x is 3. So there are two solutions. Right, how about another one? And again, you could turn this off and try it yourself. So we need two numbers that multiply to minus 12, but add to minus 4. So what are those numbers? Well, it's going to be some combination of 6 and 2, but when they're added together we get a negative number, which means the biggest number must be negative and the smaller one must be positive. So it's going to be x minus 6, x plus 2. Now you can see actually that when we solve these, when we take the x out of the bracket, we just change the sign. So this is going to be x equals 6, x equals minus 2. There's our solution. Okay, just 2 more of those. Okay, this time I've used Q to make you feel like economists. So we need 2 numbers that multiply to 10 but add to minus 7. Oh, so there's a different sort of combination here. So when 2 things multiply to be a positive number, all we really know is that they're either both positive or they're both negative. We don't know which just by looking at that. But if when they're added together they make minus 7, then they must both have been minus. So it's going to be minus 5 and minus 2 then, isn't it? When those two are added together we get minus 7, but they multiply to 10. So we get x minus 5, x minus 2, which means the solution is x equals 5, x equals 2, because that's the value of 5 if that's equal to 0. And one more like that. We need 2 numbers here that multiply to minus 48 and add to minus 8. So 2 numbers multiply to make a negative number, so we know one of them is positive, one of them is negative. This is minus 8, so we know the biggest one must be negative. And if it doesn't immediately come to you what it should be, then let's look at all the factors of 48, which is sometimes what we have to do if it doesn't come straight away. So factors come in pairs. So there's 1 and 48. There's 2 and 24. There's 3 and 16. There's 4 and 12. Ooh, that looks promising, doesn't it? I won't take the time to do the rest because I think we've got our solution here. 4 and 12. So if they add to 8, then it must be minus 12 and plus 4. The biggest number has to have the same sign as that. So it is x minus 12, x plus 4, which means that the solutions are x equals 12 and x equals minus 4. Okay, I'm just going to show you a couple of, actually, in some ways, much easier quadratics. Here we don't have the 3 terms. Here we do have a common factor, so we can factorize this in a rather simpler way. So the common factor is x. So we can take an x out of there, so that's going to leave 3x, and we can take an x out of this, so it's going to leave 4. So now we use the same logic as we used before, which is something times something equals 0. Then either this is 0, which would mean x equals 0, or 3x minus 4 is 0. And if that's the case, 3x equals 4, because we add 4 to both sides. And now we divide both sides by 3, and that's the other solution. So if they both have an x term, then actually it's much easier to factorize. But still we need this something times something equals 0 bit of reasoning. This one's a bit different. There is a common factor, it's 2, but that doesn't help us an awful lot. This has got an x squared, that's a constant, so this we could solve in quite a different way. We could add 10 to both sides, which would leave us 2x squared equals 10. Now we can divide both sides by 2. X squared equals 5. Now, a quadratic has 2 solutions. So our 2 solutions here are x equals plus or minus root 5. because what we're doing here is taking a square root of both sides. So that makes it x and that makes it root 5. However, every square root actually has two solutions, a plus or minus version. And that's because 5 times 5 is equal to, well, didn't mean to do that. 5 times 5 is equal to 25. But minus 5 times minus 5 is also equal to 25. So the square root of, say, 25 is plus or minus 5. We don't know which one we started with. So here we have x plus or minus 5 as our two solutions. Or we could write it if we wanted, x equals root 5, x equals minus root 5. That's what we mean by plus or minus. Okay, so I hope that's helped. And so here are some practice questions. So you can just freeze this screen and good luck. Here are the answers.